In this video, we are going to utilize the new Canvas view introduced in WWDC 2021 to make a game. The new Canvas view is cross-platform, so it works on macOS, iOS, watchOS and tvOS, and it's quite easy to use. So previously, when you want to draw graphics in your SwiftUI projects, you needed to use SpriteKit or SceneKit to be able to draw graphics, but now we have this native Canvas view that we can utilize to draw graphics instead. We will be making the same game that we were making a few videos before. So it's called concentric. The objective of the game is to stop a growing circle at a target radius, and if you fall inside the target radius, you win, you score a point, and if you don't, the game is reset and you have to start over. As you can see, it's very simple to use. We just have this canvas view in SwiftUI that has this context and size for drawing. So this context works very similar to other drawing contexts, and this size is just a drawing area. That's the whole screen in this case. So first, let's make a radius of the width of the size of the canvas, and then we will make a circle using the context using a fill API. So we can say like context.fill, and then we'll take the circle of the SwiftUI shape and we will derive a path to draw that circle in a frame, and that frame is nothing but, let's say, the whole drawing board, and we'll use the orange color. As you can see, we are drawing a circle, and let's try to change the width to be a fraction of the whole width, and let's see if we can make a circle with that radius. Now let's just try to make the circle in the middle of the screen. Now that we have our circle on the middle of the screen, let's try to animate the circle. And to animate the circle, we will use the new timeline view that is also introduced with Canvas view in WWDC 2021. The timeline view can provide us with a timeline, and we can extract time from it and react to that. So for this animation, we are going to use the animation context of the timeline view so that it gives us every point in time as soon as possible, so we can react to it. Because animation is real time, so a timeline view is just like giving us a continuous loop to draw the graphics on the screen. So as you can see, we can extract the current time from the timeline, saying like timeline.date, time interval since reference date, and so we will make an angle out of that. So we'll pass the current time multiplied by 60 so that it is not tiny, and then we will use that angle and in radians and to get a value, and we'll multiply that value to the radius, so that radius grows from 0 to some value. But as you can see, like nothing gets drawn because what is happening is The radius in this case becomes very large because the value of x is not tiny, it's very large, because we are using the time interval from reference date, and that's gotta be huge, and that's why the angle and radians gotta be huge. So let's try to debug this issue. What we can do is we can put breakpoints inside our canvas view, and the code will just break at that point, and we will be able to inspect values of variables to see what's happening. So let's attach it to our simulator, and let's try to break onto the line where we draw the circle, and we'll inspect the values of x and radius. As you can see, x has a very large value as we are using the current absolute time, and that's why the circle is not on the screen, because radius is very big. So what we can do is we can, as soon as the view is on the screen, we can store origin time, and we can evaluate the current time with respect to that origin time, and once we do the difference between the current time and the origin time, we will get a value that we can use to feed into our angle and ultimately the x value. And because we are starting from an origin reference time, the starting value is gonna be 0. So the radius will grow from 0 to some value. So let's see. So if you see now, our circle is animating from 0 radius to a big radius. The radius is gonna keep growing because our time is growing. So I mean, we have to cap it to some maximum value that the circle can grow. For now, let's just keep this value, and then we will make our target circle. And this time we will use the stroke API on the context to draw the circle, so we just draw the circumference of the circle. As you can see, now we see our target circle on the screen. Let's make that line width of our target circle 30, and let's try to run our app. As you can see, the outer circle, the growing circle, just covers our target circle, so we'll have to define an opacity for our growing circle. So let's do that. So what we can do here in Canvas view is we can create a copy of the original context, and we can define the opacity on the new context. So we are calling it transparent context, and we'll set the opacity to, let's say, 0.8, and we will use that context to draw our outer circle. So the opacity of the drawing is 0.8. Now let's define a maximum value for x, so our radius doesn't keep on growing. Now we'll define our game logic. So in our game there's gonna be like 3 states. One is expanding, as you saw, and one would be stopped, where we like stop this expanding circle to match the target radius, and another one would be a reset state. That would be the initial state when you begin expanding. So the reset state is the one where the game is gonna start. So we will create a game state variable, and we will set it to game state reset initially. And when game state is reset, we will use the time as 0, so nothing happens until we start the game. And along with that, we will also define a speed for our animation. We will just multiply our current time with the speed, so that whenever the speed changes, the rate of growth of the circle radius also changes. So let's see that in action. So let's make it 5 and check. So as you can see, like, the speed is faster. Now let's use our game state, and when it's reset, we will just use the time as 0, so nothing happens when we start the game. So as you can see, nothing happens. There's no growing circle anymore because the time is not changing. It's set to 0 when we are in the reset state. And let's add a tap gesture on the canvas view, and if the game state is set to reset, when someone taps on the screen, we'll set it to expanding state, so the circle will begin growing. But as you can see, it begins growing from a random radius, because even though we are using the 0 as the time, the timeline view has the time that is growing irrespective of if we are using it or not. So we'll create a start time state, and we'll set that start time state I just realized that we already have a origin date, and that's the start date, so we could use the origin date instead of creating a new start date. So we'll just keep using the origin date, and when tapping on the canvas view, we'll set the origin date to the current time, so that the timeline view starts from 0. As you can see, now the circle grows from 0 radius and not some random radius. Now let's handle the actual game mechanics in our app. So when the circle is growing and user taps on it, we should stop the circle from growing, and the circle should lock at that radius. So we will define a new state called stopped date to record the time at which user tapped to stop the circle, so we can calculate the radius out of it. So we'll set the stop date to the current date and game state to the stopped state. Now in here we will use our game state to check if we are stopped, and if we are stopped, what we will do is we will use our stopped date to calculate the current time. So we will say stop date minus origin date, and that would be our time at which we stopped, and we will use that to calculate the x value and thus the radius. So we can see that we are able to stop the circle from growing when we tap on it. Now let's handle the case where game state is stopped and we tap on it. What should happen is when game state is stopped and we tap on it, it should just reset so that we can begin playing again. And if we run the app and we tap to stop the circle, and we can tap again to go back to playing again. As you can see, we have a bug here because when we don't tap to stop the circle and it grows to its maximum radius, we have to tap twice to reset the game. That's because one tap is required to stop the circle. I mean, it's not growing, but it's growing because the timeline view is growing, but we are just not taking that into effect. So one tap to stop the circle from growing, and another tap to reset it. So let's create a condition saying that if we have stopped to a maximum radius and stopped growing, we will set our game state to stopped. So whenever we press on it, the game resets, because you already lost the opportunity to win the game. So let's instead of radius, let's use our x value, because we know that x value will grow until 1.5. So we'll use the condition if x is greater than or equal to 1.5. If that is the case, we'll set the game state to stopped and stop date to the current date. Now if you run again, and you can see we can just tap once and the game resets when the circle reached to its maximum radius. But if we try that on simulator, we see that there's a problem. It says that modifying state during the update is not allowed. So what's happening is this state update is running on the main actor, but main actor is not allowed to modify the state when UI is getting updated. So what we have to do is we have to use the new sync detached method to execute that state change in global actor. And if we try again, we can see there's no error now. And if you are wondering how actors work, you can see my previous videos where I explain about actors. Now let's create our game result, because you can succeed in the game or fail in the game. So we'll create two cases for game result: success and failure. And whenever you tap on the screen and the circle is of the same radius as the target radius, we will say the game is success. But if that's not the case and you tapped when the circle is of radius that is beyond the target radius or less than the target radius, you'll lose the game. So we'll define a condition at the end of the canvas view saying that if the radius is greater than the target radius plus the span of the target circle. So our span is defined as line width, that is 30. So let's create a constant in our structure called target span, and we will make it 30, and we'll use that target span everywhere in our code so we can easily change it. And now the condition would be if radius is greater than target radius plus target span, or radius is less than the target radius plus minus the target span. That means we are outside the target radius, so we'll set the game result to failure. And if that's not the case, we will set the game result to success. Now we will use our game result to change the color of our growing circle to red if we failed in the attempt, and we'll keep it orange if we succeed. And if we see that in the simulator, so it's always red whenever outside the target circle. That means we need another variable in the condition. So with the game result being failure and we are in the stopped state, then only we will show the red or the orange in accordance to the success or failure. So when we stop, we will evaluate to see if we are outside or inside. So as you can see, we are red whenever we are outside the target circle. Another thing that we want to do is if we are successful, so if the game result is a success and we are expanding, we will just reset the game automatically. We don't need to require an extra tap. But if we are failed in the attempt, we will stop the circle. So when you are succeeding, you can just keep on playing. So if you run in the simulator and if we succeed, you can see the game is reset automatically and you get to play again. But if you lose, the game is stopped. Let's add a score to the game as well. So we'll put our timeline view in the Z stack, and we'll put a text view on top of our graphics, the timeline view and the canvas view, and then we will have a score in our text view. So let's create a score state so we can keep track of the success and failures. So we will call our state as score, and it will be 0 at the beginning, and whenever we succeed, we will increase the score by 1. So in case of success, we'll say score is equal to score plus 1, and if we lose, so if we stopped and we ended up in failure, we will have the score reset to 0. So as you can see, we can see the score as 0 in the beginning, and when we are losing, nothing happens, but when we are succeeding, score keeps increasing till you make a failed attempt. So score reached to 12, and then when you failed, score was set to 0. So as you guys saw, like, it's now very simple to use the canvas view to draw geometry based graphics in SwiftUI, and you don't have to use SpriteKit or SceneKit for that. And if you need to draw 3D objects, you obviously will go for SceneKit, but for simple graphics stuff you just need to use canvas view. And the canvas view is cross-platform, so you get the same functionality in macOS, tvOS, watchOS as well. So that's been it for this video. If you guys liked it and learned something new, hit the like button and let me know in the comments what do you think about canvas view and the new timeline view. And if you're new to the channel, do subscribe to keep seeing the videos related to SwiftUI and the whole iOS and macOS development.